Chapter Review 2, question number 11. 20 endangered owls were caught for ringing. Their wingspans x centimeters were measured to the nearest centimeter. The following summary statistics were worked out. Work out the mean and the standard deviation of the wingspans of the 20 birds. So let's work out the mean. Mean will be sigma x divided by the total number of birds, that is 316 divided by 20, which is equal to 15.8. Working the standard deviation is equal to the mean of the squares. So we have the squares here and we will take their mean. So 5078 divided by 20. So 5078 divided by 20 minus the square of the mean. We already have calculated the mean as 15.8 and we need to take the square root, and that is 2.06. That answers for part A. Now one more bird was caught. It had a wingspan of 13 centimeters. Without doing any further calculation, say how do you think this extra wingspan will affect the mean wingspan? So we see that the new wingspan is less than the mean, hence it will reduce the mean. So we will write it will decrease the mean. It will decrease the mean since it is less than the mean. Since it is less than the mean. So that answers for part B. Then part C, 20 eagles were also caught for ringing. Their wingspans y centimeters were also measured to the nearest centimeter and the data coded using formula z is equal to y minus 5 divided by 10. The following summary statistics were obtained from the coded data. We have sigma z is 104, SZ is 1.8. Work out the mean and the standard deviation of the wingspan of the eagles. So when they have given us the coded data and they are asking us the mean and the standard deviation of the wingspan, which means we need to calculate the original values using the coded values. So let's first find the mean of the coded data. So the mean of the coded data would be sigma z divided by 20, which is 104 divided by 20, and that is 5.2. Now using this, how can we find the original mean? So we look at the coding. Coding has subtracted the y values and then divided them by 10. So to find the original value, now we will do the inverse of this, which means we will multiply the coded mean first with 10 and then add 5 to the answer. So we will do 5.2 multiplied by 10 and 2 to be added to it, 5 to be added to it, and the answer is 57. So this is the mean, and this was the mean, which was the coded mean. Let's move on to standard deviation. So For standard deviation, let's first find the standard deviation of the coded data. So standard deviation of the coded data is SZZ divided by n, square root of that, which is equal to square root of 1.8 divided by 20, and that is equal to 0.3. Now if you want to find the standard deviation, so we want to find the standard deviation of the wingspan. Standard deviation is not affected in coding by addition and subtraction. So when we need to decode this, we will only do the inverse of any multiplication or division that we have done. So since we have divided in coding, now we will multiply. So we will multiply 0.3 by 10, and the answer is 3. So the mean wingspan is 57 and the standard deviation of wingspan is 3.